For this session, we're going to talk about our new enterprise mobility services. So I kind of have an aggressive list of topics I want to go through for this session, and hopefully we'll get through most, if not all of it. So for the first bullet, what is it? I'm making this assumption that maybe some of you are not familiar with our EMS server, so I'm going to spend a few minutes explaining what it is. And then we're going to go through this process of, how do you create one? How do you start it? How do you call the EMS endpoints? How do you extend the EMS with your own custom resources and endpoints to do your own methods and procedures? How do you use EMS to get to outside databases? And by that, you can use our FireDAC data access components. Through EMS, we can also send push notifications to mobile devices, iOS and Android. And lastly, EMS can not only have our own database do authentication and authorization, you can plug in outside external credential support. So, for example, you can use it with LDAP or Active Directory. I'm going to just start our EMS server. So while I'm doing this, EMS server is either a Windows 32-bit or Windows 64-bit executable. So it starts up. We can see here by default, it includes a few administrative APIs, like what version is it running, what users are logged into it or connected to it, what groups do I have, what types of apps have already connected to it. Those are the installations, what iOS devices, what Android devices have connected to it. And we also include push notification. So just to make sure this is working, that my outside devices can connect to it, here is my Android device. And a quick way to check, I'm just going to bring up a browser. I'm going to call one of its endpoints like versions. And if it comes back with the version, yes, so EMS server is running with version 2.0, so that's all working well. And the other thing I want to just check, just to make sure that my Google Cloud ID is correct, I have a sample app I use here called EMS Push Client. So this EMS Push Client wants to talk to my EMS server, and I just want to quickly send it a push notification just to make sure the communication's working okay. On the EMS side, we give you this great EMS management console. So I just want to authenticate. I want to log into it. So I'm logged in successfully. And from this console, what users are registered to my EMS server, what groups have I created. Installations is what devices have connected to it. So here's my Android device that I connected to previously. And I can send push notifications from it. So like under installations, if I go back to the sample app and I click this button, test connection, it brings back the version just to make sure I can connect to the EMS server. We have a button here to do register installations. So this registers myself to EMS. And by doing that, it knows the type of the device, the operating systems, all that great stuff is part of that registration process. And I just want to quickly check if I could send a push notification. So under data, I just want to say hello from EMS. And where do I want to send this to? So these are the devices that are available to me. So I'm going to click this one, which is the EMS device that just got registered. So when I send this push notification, and EMS pushes the notifications out. So now if I go back to my Android device, then sure enough, there it is. So push notification got sent. All right, so now that you have that quick little overview of EMS and some of its capabilities, EMS, our Enterprise Mobility Services, it's a multi-tier framework. EMS is this turnkey middleware solution that you can use today for interconnected distributed apps. So the main parts of it are this middle piece, the EMS server, and we also give you an EMS console. So those are in the middle box here. So this EMS server is 100% REST web service that exposes a collection of predefined REST endpoints that allows, as we saw in that EMS console, I can manage users, groups, installations, and also lets me send push notifications. And that information, the users, the groups, the installations, the push notifications, that all gets stored in our included Intrabase database that comes with EMS. So then the EMS console that we quickly saw, that's a web service, and that exposes statistics about the EMS database and the EMS server usage. So, for example, from inside the EMS console, I can see the server's users, their groups, installations, I can get statistics out of the console, and I can see things like the number of user visits, number of REST API calls among the REST endpoints. And then this data can be summarized by hour, day, month, minute. So for an administrator's point of view, they can see how the EMS server is being used. And then we also gave a nice option in XE8 to let you export this data out from the web console, so you can have improved user groups analytics for offline analysis. So when the EMS server comes up, we can open up its browser, and all those endpoints we have here, like version and users, is here. But part of this is also a console. And from the console, here we can get all this great analytics about EMS. So log in as the console. I can see the users that have come into the EMS server, any groups I've created, any installations I have. So here's my Android device that we just connected to it. And then these great analytics as what's going on inside of it. So I can see statistics like total clients, API calls, user API calls. So all of the API calls that people have that are using inside of this EMS server, I can get some nice statistics on this. So I could find out what endpoints, what resources people are going after, and where should I spend my most time on what resources and what endpoints. And here we added this new feature in XE8 to export this information out to a comma-separated file for offline analysis. So that's a quick peek at the EMS console. All right, so that was a quick overview of the EMS console, and before that I showed you the EMS management console that let us do additional push notifications to the EMS server. So what's nice about this EMS server is you can extend the capabilities inside the EMS server by adding one or more what we call EMS packages and modules, and these you create either using the Object Pascal language or the C++ inside of C++ Builder. And it's going to be through these custom endpoints that you create that you're going to expose your data and operations. So for example, you can create a custom endpoints that's going to permit a mobile client to request data from your company's database. You can create another set of endpoints that's going to allow clients to send updates back to the EMS server, where your custom code can evaluate these changes and post changes back to your central database. Now, and because these custom endpoints are written either in C++ or Object Pascal, they can use all of the power that you have inside of RAD Studio to perform these necessary tasks. So as we see here by these arrows between the EMS server and the entities in the right-hand rectangle in the diagram. So if I need to get to outside enterprise resources, whether it's back-end as a service providers or any of our enterprise databases, we have the FireDAC connector to get you access to data access to communicate to all of these back-end enterprise databases. And if you don't already have a SQL database server to store data for your EMS application, the interbase license that's included with EMS. You can use that as your SQL database. All right. So for the EMS architecture, so what we showed inside of RAD Studio, it supports all of these standard protocols for network communication. So you got your Bluetooth, you got your Wi-Fi, you got your network Wi-Fi, and it also includes a wide range of components that simplify use of these industry standard services. So REST calls. So your custom endpoints can provide your EMS clients with a gateway to all of the data wherever it resides, whether it's in the cloud, inside your firewall, or even in local files on your server. So wherever your data is stored, the EMS server provides this nice secure gateway to get to your data. So EMS out of the box already supports authentication and authorization. So you get that out of the box, and you can also tell it to use SSL, secure socket layer encryption of the client-server communications. So for these clients that you create, since EMS exposes its endpoints using industry standard REST API, any platform can host EMS clients. So using RAD Studio, you can build native mobile apps for both iOS and Android, and these can use the EMS client components to interact with the EMS server. And I mentioned this before, but if you need a secure local storage on your mobile devices, then the good news is EMS also includes licenses for the Interbase to Go, and that's a very small footprint transaction supporting database server that can be installed inside your iOS devices and inside your Android devices. And that database is allowed to be encrypted. So any customer information or any financial data can be encrypted on the device. So that's all pretty cool. But with EMS server, you're not just limited to mobile client applications. So the EMS client applications, they can be desktop, Windows, VCL applications. They could be internet services. They can be web services. They could be console applications or any type of application that can send and consume HTTP requests. And you're really not limited to creating these EMS clients inside of RAD Studio. So, for example, you can write web pages that use JavaScript. They can access these EMS endpoints. So that's all exciting. And lastly, in XE8, we added a bunch of cool new features inside of the EMS server. So we improved using REST API publishing. I spoke about the external credentials for user authentication and authorization, like plugging it into Active Directory or LDAP. We added push notification server support for iOS and Android, so you can deliver event-driven notifications to the end user's devices through EMS. We have REST API publishing. We added database connection pooling. I saw that button. We saw that button inside of the EMS console that you can export the data from the web console, so you can have improved user group analytics. And the EMS management console that I showed previously, where allows me to manage users, groups, installations, push notifications, and more. EMS comes in two versions, either a 32-bit Windows version and a 64-bit Windows version, and they get installed in the RAD Studio bin or the bin 64 folder. So to start the EMS server, it's just this executable EMS dev server. So when you start it for the first time, it's going to invoke this EMS setup wizard. And if you just click all the defaults of the EMS wizard, it's going to end up creating this EMS development server that we see here. So if we look at it, it says it created our EMS server configuration file. It creates our EMS server Interbase database. In my case, I'm using the EMS development server, so it's a not licensed version. So it's the development version that you get inside of a RAD Studio, and it allows me to test with 5 default users. And then we give you these default administrative APIs. What version of the server am I running? What users have I logged? What users are inside of my server? What groups have I created? What installations? What devices I've connected to my EMS server? And it also gives me the ability to send push notifications. So all of this comes by default. If we take a quick look at where these files get created, I have it here. So when you do this by default, it puts it in your users public documents Embarcadero EMS. So EMS server.ib is the interbase file it creates. The EMS server.ini file is the configuration file it creates. So if you move the EMS database, here's where you give it, where you put the EMS database. You can set extended passwords on the encrypted interbase database. You have your connections. And if I go down to SSL, so if you want this to support SSL, there's an option to select SSL. For the push notification, I'll tell you where those two pieces are. So to do Google push notification, like David I showed you with Kenvey, you had to go up to the Kenvey account and get their app ID and app master key. Same thing applies for Google. So you go to developers Google account and you get a free Google Cloud messaging ID, and you put that API key here. That's for Google. For Apple, if you have privileges to create your own Apple push notification certificate. You can do that yourself or get your admin to create it. You'll end up with this push notifications certificate, and that's needed to be able to push notifications to Apple devices. So that's kind of what really needs to be done here for what we're going to cover today. Okay. So as we see here, it's this EMS server. It's running on my Windows IP address in the default port of 8080. So now you're able to call these EMS administrative APIs. So EMS being this turnkey middleware server. So out of the box, you get these administrative REST APIs for built-in resources to do version, users, groups, and installations. And as you can see here, these resources expose endpoints like get users. You know, for users, I can either get all users or get an individual user. So EMS is using standard HTTP, REST, and JSON, JavaScript object notation. So we can call these endpoints from a browser. So if I open up a browser, you know, by default it says do the version endpoint. Instead of version, I can ask for users. And here's all the users that I got registered. So you see for users, it did the get, so it returned a JSON array of all of my users. But if you looked at users, it also had a get item. So I can pick an individual user, and I can ask just for its JSON object to be returned. So if I take this user here and say I don't want all users to come back, I just want this individual user with this individual ID, then instead of getting back that JSON array, we just get back the JSON object just for this one user. So one way of accessing the EMS server is through this browser for testing purposes. So by default, we have these administrative APIs in here, but we want to now be able to extend the endpoints and the resources with our own custom resources and endpoints. So when you extend this EMS server using runtime packages, that we're going to define and register resources, and we do that by this nice wizard inside of RAD Studio. So if you go to File, New, Other, you'll see for both C Builder and for Delphi, you have a new EMS node, and from this node is where we can create new EMS packages. And inside these EMS packages is where we create our modules, and those modules become our new endpoints and our resources that we can use to extend it. So, for example, if we want to create a new custom resource, a new custom endpoints, we'll say package. So you can create an empty package that doesn't register the resource. You can do that later, but in our case, we want to create a package with the resource that we want to get registered to the EMS server. Resource name, I'll just call it demo for now. You can put it inside of a data module. Now, data module is usually reserved for if you're going to connect to back-end databases. It gives you a nice surface to add, data access components, or it could be in a standalone unit. But I'm going to pick it as a data module because I like working with data modules. And then these are the endpoints that you can ask for or include. Get item, post, put item, and delete item. So you can select them all if you want. So this module gets created. And as you see here, it's a BIPL, so it's a package. So this package cannot run on its own. So to help us, either on the run parameters, we see here that when we run this project, it's going to first start the EMS developer server, and then it's going to load this package into the server with our newly created custom resources and endpoints. So if we look at what it creates by default, you'll see here it creates created a resource name of demo that's inside of a T data module, and we have our get and our get item post. If you take a look at some of these have this resource suffix item, and those are the ones that allow me to pass parameters to it. So, for example, if I just did a get I get everything returned. But if I did a get item, I can also pass an individual item like we did for get users to return one individual user. We have the same for put item and the same for delete. So inside of here is where you would add your additional custom resources and endpoints. So these are the same files we created. This time I called my resource name my resource inside of a T data module. And what I did for this one, give me some more real estate here, is I created a new custom endpoint called reverse string. So its signature is very similar to all of these others. So, and because it's a reverse string where I want to pass it in, I want to pass it in a value, a parameter, and then run the reverse string on it. It has this resource suffix on here. And then to implement it, similar to how we used to do with the if you ever ran a data snap server and you asked for the sample methods, this is kind of one of those sample reverse string methods we did there. So here's the implementation of reverse string, which is right here. So get the reverse string, pass in an item, and then do the reverse string function on it. And that reverse string function is part of system string utils. So the great way, or the great reason to use RAD Studio to create these custom resources and endpoints, you can use all the power of Delphi and or C++ Builder to create these custom endpoints for you. So we're going to show another EMS server where we included a FireDAC and a data module to get to backend databases. So kind of just how we did before, we ran the EMS wizard. We created this EMS FireDAC resource package. Inside of the package, we have a module, and on the data module, we added our FireDAC connection. So this FireDAC connection will connect to whatever backend database you want it to connect to. It's got query components that queries backend database. You can check it here just to make sure it works. Query customers, query the orders. That's all working fine. That's the backend EMS server where we have extended inside of this module. We created this resource name called test inside a data module, and it's got endpoints like get records going through FireDAC and post updates going through FireDAC. And we do their implementation here. And we see here we're using the FireDAC schema adapter. It knows how to save to stream and load from stream. So it's a very powerful capability of this FireDAC schema adapter. Once we return the JSON object out from EMS through FireDAC, we can now take that data and convert it to a nice tabular form to display inside of tables. Let me show you this running and we'll see what it looks like. So again, we see here we created a new resource called test that has endpoints of get records and post updates. So to test it, so if we just ran test, it should return everything back from the database. So if I open up a browser and I pass it test, it goes through EMS, uses the FireDAC connector to get to the backend database and returns a nice JSON array of all the data. So that's cool. So now we can use this endpoint inside of client applications. So for EMS, we include an EMS provider. So the important properties here is where is the EMS server running, what's its URL host, and what port is it running on. There's an EMS FireDAC client, and this tells us the resource that we want to hit. So in our case, we want to hit the test resource. So when I run this, and if we looked at the two functions here, get tables and post tables, so when I call get tables, inside of that test resource, there was the get data endpoint that's going to return data from the EMS server through FireDAC, and the other one was post updates. Any changes we make will get posted back to the database using this FireDAC data access client component. So EMS server is running. We run the client. So when I run the client and I do get tables, it does the get data and returns back the data. So you get that nice JSON array that comes back, and we can format it nicely into this master detail type of format through that FireDAC schema component. So that does that very well. Then any changes I make here, if I make a change and I post it, it will do its post. So that works out all fine. So that's a quick look on how you can use EMS custom packages and include the FireDAC data access components to get to back-end database resources and return the results back to these call-in clients. Right now we want to get into push notifications. So for push notifications, like you see here, we can even use VCL client apps to send push notifications to mobile connected apps to EMS servers, or they can be FireMonkey multi-device apps like we saw running before. So before I had this running on my Android tablet, it looks like this. So in XE8, we added push notification support inside of EMS for both Google Cloud Messaging and Apple push notifications. So you can have a mix of devices registered into EMS, and it's very simple to do the registration. I'm going to say the most coolest new feature we put inside of VMS is be able to do push notifications, but it's very critically important for these mobile architectures because it's the only way, it's the conduit to notify mobile applications even when they're not running on the device. So what's cool about that, there's no background thread that's needed. Part of the Google Cloud Messaging and Apple push notifications does all of this push notifications for us. So we give you this ready-to-use component called push events, and this is what it needs to do the push notification. So the only two components I have on here to enable me to do push notifications, one is the EMS provider, like we saw before. Give me the IP address and the port of where the EMS server is running, and then we drop a push events on here, and we just connect the provider name of push events to the EMS provider. And then push events has a event called push events received. So the EMS sends out the push notifications, and then when the client receives the push notification, it triggers this push events push received. And here at the very low level, we package up that push notification either coming from Apple push notification or from the Google Cloud Messaging. So it's as simple as that. So here's a VCL application. The only two things I need to drop onto a VCL application to send push notifications to client is, once again, drop the EMS provider on here, tell it where my EMS server is running, IP address and port. And now here we have the back-end push component. This is a component for requesting a push notification, not receiving it. And it can be any type of application, including the VCL application like we see here. So to trigger the notification to do a broadcast, all you really need is a one line of code. So once we have an EMS provider on here and a back-end push component, all I have to do is tell it the message I want to send and then call its push method, and it knows how to broadcast, push that message to all of the connected devices to the EMS server. So that's also pretty cool. All right, one of the few last things I want to show you here is how we extended EMS to do external credential checking. This was a request from customers saying not only did they want to allow our included intrabase database to do authentication and authorization, but some folks had external login authentication like LDAP or Active Directory. Inside here, we added a new resource called Custom Login that knows how to go outside of the EMS server, take the user ID and the password that you provided to us, and use external credentials like LDAP or Active Directory to do this. If we go into the code, here we have a resource name called Custom Login. And here we do it a little bit differently. So when we do the EMS custom login resource, it's a different resource type and the registration is a little bit different, because by doing it this way, we're telling the system not to expose an API, but for doing a registration. So instead of letting EMS check for the username and password in our included EMS interbase database, you can prompt for the username and the password, and then you can check it from an external credentials database. If I run a client, I have the option of either using our own included intrabase database to check for login. So I have my test 1 and my test 1. So this is going to our own internal intrabase database, and it's happy it logs in correct. But if I switch this to custom resource and I do the same thing, so this is going against the Embarcadero credentials, and test 1 does not exist there. So if I try to log in there, it says, sorry, that username or password is incorrect. So it's nice to know you can take EMS and now you can add this external credentials checking support for the back-end databases.
So that was a quick look at a whole bunch of different technologies associated with enterprise mobility services, including push notifications. We have lots of information about push notification and notification-based application development, both using back-end as a service systems like Parse and Convey. Serena DuPont's done a whole section of blog posts on back-end as a service and push. Also, Al put a bunch of links just now in the Doc Wiki. We have examples not only for EMS, but for these backend as a service and using the components that are available for receiving a push as well as pushing to a backend service with the backend push components. So you can go to RAD Studio 10 Seattle and just go to the component palette after you create a project and type PUSH in the component palette search, and you'll see the different push-based things, as well as put provider, and you'll see EMS provider, Parse provider, Convey provider. There's also replay sessions on CodeRage of using Apple Push Notification Service and Google Cloud Messaging. Other tutorials, skill sprints we've covered. So there's lots in the world of notifications, as well as now with Windows 10 notifications. There's a lot that you can take a look at, of course, if you need push-based technologies in your app.
Correct. Yeah, like I said, these mobile devices, push is what you need. There's no other way to communicate with them. So they all work through these push notifications. And what's nice about using either Google's service or Apple's service, I think Google is still free. Apple might be a charge associated with Apple based on amount of data sent.
Well, as a developer, you get, you pay what, $99 a year, and then you can build your applications that use the push service, and there's no charge other than the $99 a year. You can push. Parse and Convey had charges, and they also had free levels, and Parse may have gone completely free for push. I'm not sure, but you can search. Parse is owned by Facebook, and Convey is their own. There's also Shepard's App 42. You can search for App 42. Those have either free levels or paid levels. As far as EMS, there's always the discussion about should you use it and pay for the deployment and the number of users, or use something else. And the guidance for me is always build versus buy, right? You can use DataSnap, you can use other multi-tier technologies, build user management and authentication, build object and data storage, build secure servers and on-device database servers and the analytics and everything else. You can assemble and build all of that yourself. But if you need a turnkey application, or if maybe you're an OEM or a value-added reseller, or an ISV, or a small business where you're selling, maybe you want to build an app that ties mobile and desktop and server for a small business in your local town, maybe it's an accounting office or whatever, then a 5 or 10 person installation fits very nicely. But the best thing is contact our sales office. They love to do deals for deployment of EMS-based solutions. So contact our reselling partners or sales offices and talk about what you might be able to do. And deployment's very easy, right, Al? I mean, after you build and test using the developer editions, then you can take your package or packages and put them on an IIS server, scale them up big time, or even scale them to fit the size of the target business that you're working with.
That's correct. We'll give you a DLL file that you can just drop into a Microsoft IIS server, and then you inherit all of its huge scalability capabilities and all of its authentication and HTTPS, secure socket layer, all inside of that production IIS server.